My name is Kevin Lin, and my project is on the effect of temperature on electrolysis. The electrolysis of water is essentially the process in which a current runs through a solution of water and creates hydrogen gas and oxygen gas. This hydrogen gas has applications for many fields, including medical treatment for some diseases and protection for welding applications. Temperature has been shown to have an effect on the rate of chemical reactions, therefore, I hypothesize that an increased temperature will increase the amount of hydrogen produced by electrolysis. The independent variable for this experiment was the temperature of the solution, while the dependent variable was the amount of hydrogen gas that was produced in milliliters. There are four temperature levels that were tested as shown, and the room temperature, which is 24.2 degrees Celsius, was used as the control. Each test was 10 minutes with 2-minute intervals in between, and 12 volts was supplied to the system. pH was initially measured, however, it gave no results. Therefore, current was used along with the amount of time that elapsed in order to calculate the amount of hydrogen that was produced. Using these calculations, the amount of hydrogen and oxygen in milliliters could be calculated. This was the initial model of the design, and in the actual model, you can see the voltometer that was used and the pH meter that was used to regulate the pH and to measure the current. The results show that higher temperatures have been shown to increase the amount of H2 and O2 that was produced during electrolysis, and the T values for the T test that was used for statistical analysis indicate that these results are statistically significant. There was relatively low production at 4 degrees Celsius and 14 degrees Celsius, while higher production was seen at 33.4 degrees Celsius, meaning that as a result, the data supports the alternative hypothesis, which means a higher temperature is correlated to a higher degree of electrolysis. However, there are some delays between measurements, and the temperature of the solution could increase and decrease throughout testing. However, ultimately, the data supports the hypothesis.